The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmer's market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and try to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the 8th and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.
TRES 2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, For comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat. So there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Karat EXO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're used to thinking that asteroids are the only free-floating rocks in space, but things like OTS-44 make you think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS-44 collides with any other planet, it would utterly destroy it and go on floating as if nothing happened. Scarier still, scientists are sure there are millions of such rogue planets out there, just waiting to be discovered. There's no hard proof of their existence yet, but theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting in their atmosphere would get into a reaction with carbon and transform into CO2, forming black toxic clouds. On the ground, there would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. Hard to imagine anything that would survive such conditions. You know what? Every species on the planet needs to adapt to the world around it to survive. Human beings are no exception. We didn't exist millions of years ago. The oldest skeleton of a modern person ever found is about 196,000 years old. But even in this relatively short period of time, our species has evolved a lot. In fact, we've never stopped evolving. At least that's what some scientists think. And some of our traits seem to prove it. About 20,000 years ago, I wasn't around then, only children could drink milk without getting an upset stomach. But then humans domesticated animals like cows and goats. A new gene developed in people's bodies down the generations. Today, about a third of all the world's population can drink milk in adulthood. In fact, this ability actually developed independently among different groups of people all over the planet. Our jaws are also not as big as the ones our extinct relatives had. They got smaller because our soft processed food is nothing like the diet of our ancestors. Our teeth themselves have become smaller too, and some have even disappeared completely. Plenty of people may never develop third molars, known as wisdom teeth. But for our ancestors, these teeth were vital. Third molars usually develop when someone is 18 to 25 years old. By this time, most of our ancestors' teeth had become worn out, so the third molars were possibly replacements. But some slight changes in human anatomy may have nothing to do with evolution. For example, people have generally gotten taller over the past few hundred years. The most likely cause of this is simply better nutrition, as well as access to modern medical care, and perhaps basketball. But what changes await humanity in the future? Of course, nobody can tell for sure, but the experts do have some interesting theories. One possibility is that we could get shorter as we adapt to life on our overpopulated planet. Studies have shown that shorter people consume a lot less energy and resources than taller people. In the era of hunter-gatherers, humans didn't meet many others in their day-to-day lives. Now, people have to adapt to life in densely populated cities. And who knows, maybe given enough time, our genes will respond to this change and reduce the average person's height. Another possibility is that more and more people will look alike. Modern humans travel a lot. As different types of people interact and have children, our genes are becoming more and more mixed up. In the future, this might make some physical characteristics a lot more unusual. The average-looking person might have darker skin and hair, and traits like freckles or blue eyes could become a rarity. Some scientists think that evolution won't play an important role in our future at all. Unlike our ancestors who lived millions of years ago, we now have a very advanced culture based on cooperation and modern technology. So, we no longer need to literally struggle to survive. Because of this, we may actually stop developing as a species and remain pretty much the same far into the future. If our evolution does continue, though, there's a chance we'll become more complex and intelligent creatures. Because of technological progress, the way we deal with problems could depend more on our intelligence than our physical abilities. So our brains might become larger. This may already be happening. I know mine is getting bigger. Some scientists' measurements show that the skulls of Americans are actually getting bigger on average. The room in there for the brain has increased about the size of a tennis ball. Or maybe the opposite will happen, and our brains will shrink. This direction of development has actually been around for a lot longer. Some people think that the male human brain has been getting smaller for the past 20,000 years. Hey, just ask females. If it continues to decrease at the same rate for the next 20,000, it'll end up being the same size as the brain of an archaic human who lived about 2 million years ago. Wait, does that mean we're becoming less intelligent? Well, a bigger brain doesn't always mean greater intellect. We just might be evolving to have smaller but super efficient brains. Another theory is that our bodies might learn to use calories from fast food. Things like pizza, fries, and donuts contain trans fats. These chemicals are difficult for our bodies to digest. But what if humans of the future somehow adapt to this kind of food, if we eat it for long enough? After all, the same process has already happened with milk. In a few thousand years, people may develop genes that can break down trans fats and absorb something healthy from them. If they still enjoy eating burgers and fries, of course. Donuts. People of the future might have less hair than we do today. Hair was vital for our ancestors. It helped regulate their body temperature, keeping them warm in cold climates and cool in hot environments. Even today, we still have practically the same amount of hair as many apes do. But some scientists have pointed out that our hair is nowhere as near as important to our survival as it once was. Since we now have modern heating systems and clothing for any environment, maybe given enough time, we'll become a lot less hairy. Then they'll be saying, he wasn't very fuzzy, was he? Yet our hair still serves many purposes. Our eyelashes protect our eyes from dust, and eyebrows keep them clear of sweat. Some experts think the hair on our heads even helps stabilize the temperature of the brain. So we probably won't become completely hairless, just a little smoother. And now the bad news. Human beings of the future may have weakened immune systems and become more vulnerable to illnesses. New medical technology and antibiotics can improve our health, but there's the risk that they could make our immune system lazier and unprepared for fighting infections over time. Many generations down the line, it's possible that the human body might not be able to withstand even simple diseases without serious medical help. Today, human development isn't determined by biology alone. Technology also plays a role. Maybe one day, people will stop waiting for evolution to give them what they want and begin to change themselves using advanced tech. Doctors already use artificial devices to help people with health problems. So who's to say that machinery and computers won't be used in the far future to completely change our physical abilities? Our descendants might get different kinds of brain implants. Or it could be that people will be equipped with artificial eyes with camera functions. But in this scenario, we could also end up being less knowledgeable. Why learn a foreign language or remember historical dates when all the world's information has been downloaded right into your brain? If human beings eventually become a multi-planet species and colonize Mars, our bodies could begin to adapt to life beyond Earth in interesting ways. The contrast between the environment on Earth and the red planet is so huge that evolution may actually speed up. In this case, humans could adapt to the new physical conditions in as little as 6,000 years, or just a few hundred generations. In the low-gravity environment of outer space or alien worlds, the structure of our muscles could change. We won't need some of them, while others will develop more quickly. The amount of body fat we have may increase in a cold climate. Low temperatures may also make us grow thick, long hair again. Our skin may become more pigmented and therefore better protected from harmful UV radiation. And our eyelids might get thicker to protect our eyes from all the cosmic rays outside the Earth's atmosphere.